So this video is on Integrated 1, Chapter 4, D-Day number 2. So first thing I'm going to do is I'm going to look at my X's. They are square footage of a house, and my Y is the sale price for the house. And I'm going to look and see what is my smallest and largest X. So looking at this, it looks like my smallest one is 1,131, and it may not always be your first value. And my biggest one is 2,272. So I think I'm going to start on my X-axis at 1,100, go by hundreds up to 2,300. Okay. So on my X-axis, I am going to label this square feet. And then I am going to start here and have this start. And I'm actually going to flip my paper. So I'm going to rotate it clockwise. Yeah, that'll be good. So this is my X-axis, but I've rotated it. And so I'm going to start here and have this be 1,100. This one, 1,200. And I'm going to keep going. Whoops. Skipping every other. And I'm going to go by hundreds. Okay, so I'm going to pause and do that. And then I'll restart the video. So on my X-axis, you can see that I started at 1,100. It went by hundreds here, all the way down to 2,300. Okay, again, this is my X-axis. I'm going to rotate this back. And then I'm going to do my Y-axis. My Y-axis is going to be sale price. And I want to figure out what the smallest, I'm thinking the smallest is 407,000. Let's see. Don't think I see anything below that. My biggest one's going to be in the 500,000s, and looking at it, I got, I think 5,400. So I'm going to start at 410,000 and go up to 540,000. And again, this is my sale price in thousands. So I'm going to type sale price in thousands. Oops, thousands. And let me rotate this. Okay. So that's going to be my sale price on thousands. And then for this, I am going to be starting. Oops, just lost it. Try again. So I am going to be starting with my 407,000. So I'm going to be 410,000 and 420,000, 430,000, and so on. So let me pause and get that done. So on this one, I am starting at, again, on the Y at 410,000. And I'm going up by 10,000. And at the very, very, very end, I have 540,000. So now I'm going to plot these points. Okay, so I'll start a couple and then I will pause and do the rest. So 1,131. Okay, let me get a different color here, make it a little better. So I might make it even. Let's see how that is. Yeah, that's okay. Maybe a little fatter. Okay, so 1,131. Okay, so 1,100. Okay, this would be 1,150. So somewhere in between here. And I'm going to go up to 407,000, really, but 407. So it's a little less than that. So I'm just approximating. Let's just say it's about there. The next one, 1,300. So 1,357. So this would be 50. So 57 somewhere here up to 420,000. And then I have another one that's up at 420. Whoops, 420,000. Sorry, I didn't go up high enough. 420,000. And then the other one that's 424,000. So it's going to be just underneath this. And then I'm just going to plot the rest of them. So let me pause and plot the rest of them. So here's my finished graph. Okay. So you can kind of see it here. So now what I'm going to do is I'm going to put this data into my graphing calculator. Okay. So to do that, what I'm going to do, turn on my graphing calculator. I am going to go to, well, number one, I'm going to go to mode. And on mode, I'm going to go down to stat diagnostic and make sure that it's on. Okay. Then, because that's going to give me my R, my correlation coefficient when I do my analysis. Then I'm going to hit stat, edit. If there's any data that you don't want, you can come up and highlight L1 or L2 and press the clear button, not the delete button. So I'm pressing the clear button, clear, and then I enter. And again, clear, and then enter. And then I'm going to start adding the data in. Okay, 1311, 1357, and so forth. So let me pause and enter that in. For my X is going L1 and my Y is going L2. So I have my data in the calculator. Okay, now I want to make sure and I check my sum. So you'll notice over here, I have a checksum for my X's, and then I have a checksum for my Y's. So to check your sum, to make sure that what it's doing is it adds up all of these, but instead of you doing it, your calculator will do it. So if I go stat, over to calculate, and I go down to number 2. Okay, number 2. I can just press 2, but I want to show you guys this is number 2. And I hit enter, 2 variable statistics. And I just hit return. This is going to give me, the values here. This one here is my checksum. So I see I have something wrong because my checksum should be 33815. So I need to go and find what that is. And my Y is wrong. So I'm going to double check them because it needs to be that sum. Okay, so I rechecked my values, found 2 little mistakes. So now I'm going to double check it. I'm going to go calc. I'm going to go down to 2 variable statistic, okay, number 2. And hopefully this time it's going to match. Okay, so my checksum for my X's should be 33815, so that works. My checksum for my Y's is 1009700. Okay, so I'm good. So that's good. So now I'm going to find my line of best fit. So I'm going to go back to stat. This time I'm going to go to calculate again, but I want number 4. Okay, number 4, linear regression. Okay, so got my L1s, my L2s. Right here, I'm going to stop. I'm going to store. So I'm going to go the green alpha button and the trace button. I'm going to put my y1, and it's going to save this in my y's for me. So this tells you your equations y equal ax plus b. This right here is your a. That is going to be with your x. And then this is your b. We're going to want two numbers after the decimal accuracy. So let's count this as 116.45. And this one's going to be 293,301.81. Okay, so I'm going to write those here for line of best fit. So I am going to go y equal 116.45x plus my b, which is 293,301.81. Now I've got my r here. That's my correlation coefficient. So I'm going to come down here to determine the correlation coefficient and give four numbers after the decimal. So it's going to be 0.8249. Okay. So that is going to help me know that this is going to be a positive and also strong correlation, because remember, my R is between 1 and -1. So if it is equal to 1, that means it is every point's exactly on the line. And if it's equal to -1, that also means every point's exactly on the line. But it is a negative line, where the other one, when it's equal to 1, is a positive line. So we want to keep that in mind. So I'm pretty close to here. I'm just going to remind us that's what my R is in between, but this is my R. Okay. So the next thing is on this, if I want to see the graph, I want to make sure that my line of best fit, that my stat plot is on. So I'm going to hit the second button and the y equal and make sure my stat plot's on. So mine's on. Then to see my graph, I'm going to hit zoom. And I'm going to go down to number 9, zoom stat. Okay, number 9, zoom stat. Okay. And there's my graph. And there's my line. Okay. So now what I'm going to do is I am going to do my sentence frames. And actually, one more thing I'm going to do while I have the calculator up. I'm going to want to actually graph this line. But I've kind of distorted my graph because I am not starting at, my first value here is 1,100, which means I'd be going every tick mark by 1,100, which I'm not. But with statistics, a lot of times you can do that with the graph. You can kind of start with your low to high and low to high. But what that means is I can't just come over here and come up to 293,301 and start graphing, because it's going to be distorted. So I want to find two points, okay, from this. And so what I'm going to do is I'm going to use my calculator. Okay, let me just move it. And I am going to choose some values here. So let's say I do like 1,200. So on this calculator, if I press the second button and trace, and I come to number 1 value, I can put in an X value. So I said 1,200, and that point's going to be given to me there. So I'm going to jot that down. Let me move this back. So one point that I'm going to plot is going to be 1,200, comma 433,038.45. That's going to be 1 point. Let's find another point. Let's space it out a little bit. So let's say I do like maybe 2,000. So let's say I do 2,000. So I'm going to hit second and the trace button one more time. I'm going to hit value and put 2,000 in. And it's going to give me that Y value. So 526,196.2. Okay, so those 2 points I'm going to plot. Okay, so to plot those 2 points, I'm going to do it in a different color, number 1. And so I'm going to come to 433,000 basically. So 433,000. So I'm going to come here, okay, to 433,000. So that would be 435. So somewhere, let's just say here. Okay, that's 1 point. The other point is going to be 2,000, comma, let's say about 526. Okay, so 2,000, 2,000, 526. Okay, whoops. So 2,000. Let me just make sure I'm at 2,000. 2,000. 526. So that'd be 525, 526 would be slightly above it. Okay, so I've got those 2 points. So now I'm going to draw my line. Okay, so I'm going to get my line tool and I'm going to draw my line through, oops, let me get my line, sorry, through this, through those points. Okay, I'm going to adjust it slightly off here. That's okay. Okay, so there's my line. Oops, just moved it. Okay, there's my line. Okay, and again, I use these 2 points that I found from this equation. I put 1,200 into this equation for X, and I put 2,000 into this equation. So now I'm going to do my sentence frames. Okay. So for my sentence frames, I'm going to say there is a strong, positive, linear relationship between what the X and the Y is, between the square feet of a house and the selling price. Okay. Interpret the slope. So for the interpret the slope, this right here is my slope, 116.45. That's the number I'm going to be using. Okay, so I'm going to say as, I'll say on average, as the, and here I'm going to put in the X variable. So as the square footage of a house increases by 1 square foot, and this is going to be my Y, which is the selling price. The selling price, and if you look at the graph, it's an increasing graph, right? So the selling price increases by about, and this is the Y, okay, about $116.45. Okay, so every square foot, the price of the house increases by $116.45. Interpret the y-intercept. So interpret the y-intercept. I am going to be using this number, and the sentence frame for this is when your X is 0, your Y is, okay? So when the square footage of a house is 0, the selling price is about 293,301.81, and that's going to be your sentence frame. So now on the next one, predict the price if the home has 1,951 square feet. So what you're going to do is for this one, you're going to put that amount. Let me get rid of this. You're going to put that amount into your equation. So I'm going to take this equation here. Let me just copy it. Copy. And whoops. Copy. Right again. Copy. And let me paste it here. Okay. So into this equation, I'm going to put the 1,000. So whoops, I'm going to get thinner. Okay. So I'm going to be putting in 116.45 times 1951 plus 293,301.81. I'm going to put that into my calculator. Okay. So I can actually, if I wanted to do it here, okay. So I can go in second trace value and put in 1951. And I end up getting from my calculator. Okay, so from calc. And when I say that, I mean like from my graphing on the calc, 520,490.29. Okay. Now, if I'm just putting that into my calculator and I'm just trying to compute it, so 116.45 times 1951 plus 293,301.81. Okay, put that into my calculator. You see, I get a slightly different answer because we had rounded here in our equation, but on the calculator kept it exact. Okay, so this is what I get if I just use the equation that we wrote. This is what I get if I use the value from the calculator. Okay. Now, the next part, we're going to do residual. And residual is going to be actual minus predicted. That's the formula for residual. Okay. Now, for the actual, for 1951, I get that from my table. So I come here and my actual is 525,000. Okay. So my actual is 525,000 minus, and then I am going to be subtracting this amount over here. Okay. Let me copy and paste. Okay, so I'm subtracting the predicted value that I had. So when I do that on my calculator, okay, so I'm putting that in 525,000 minus 1,5. Sorry, not 1. Sorry, take that off. That's not a 1. That was part of my box. Okay. Minus. So let me go back. Okay, so 525,000 minus 520,495.76. I end up getting 4,504.24 for my residual. Okay. If I am doing this using residuals on my calculator, I might get a slightly different answer. If you want to do that, you're going to go to stat, you're going to go to edit, you're going to go up to your L3, and what you want is the button that says list. It's actually the stat button, but with the second button pressed. So it's this one here. Okay, stat, but I want list. I'm going to press the second button. So when I'm sitting on L3, I'm going to press second and stat for list. I'm going to press number 7. Now, if you did not save your equation, you're not going to see residual as a choice. Okay, if you didn't store it. So now if I wanted to see what it was for 1951, I can come here. Okay, and 1951, it is, so this is again on calc. It's going to be 4509.7. So you see we're slightly off because again on the calculator, it kept things more precise. Okay. Now, the next thing we're going to do is we're going to interpret the correlation. So we found our R already, and I'm going to use the sentence frame. Since R equals 0.8249, and then I'm going to say is either close to or far from, and is close to either 1 or -1. So is close to 1. There is a strong positive linear relationship between the square footage of a house and the selling price. Okay. Now, on the next part, these ones are kind of what we were doing before with the upper and lower bounds. So with this, you want to look and see here, what is your biggest residual? And when you're looking, you actually want to get on the number because sometimes it doesn't give you enough spaces. So I'm going to go up to the top here and see which one. And actually, well, we'll see which one is the biggest off. So this is 1800, 3100. Let's see. 35. So that's the most so far. No. So 42. Okay. So the most is going to be this -42. So the biggest residual occurred at 2,272 square feet. But the residual was, okay, where the residual was the following. It was a -42869, let's say, okay. I'll put 0.84. I'll go to 2 numbers after decimal accuracy. So what I'm going to do is I'm going to take this residual. Okay, I'm going to take the absolute value of it, which basically means a positive 42,869. And I'm going to add it on to and take it off of this equation. Okay, so let me get rid of this for a second. Okay, so I'm going to copy this and let me just paste that down here. Okay, whoops, I lost it. Okay, try it again. Copy, paste. Okay, and I'm going to paste it one more time here. So what I'm going to do is onto this, I am going to add on to the y coordinate 42869.84 to get the upper, and to get the lower, I'm going to subtract 42869.84. Okay, so let me just do that math on my calculator. Okay, get to a normal screen. So I'm going to put in 293,301.81, and I'm going to add 42869, so 42,869.84. And I'm adding it on to the 293,301. And when I do, I get 336,171.65. So my equation, my final equation for my upper bound is going to be 11645x, and then plus 336,171.65. This is an equation that's going to be parallel to the other one, okay? And it should be above it. And I'm going to do the same thing for my lower bound, but this time I'm going to subtract it. So I'm just going to come up here. I'm just going to highlight this, hit enter, and then I can just change this from a plus to a minus. And so I get 250,431. So my equation is going to be y equal 116.45x plus 250,431.97. That is going to be my equation. Okay. Now, just to show you guys, if I was to put this onto my calculator, okay, I could come to my y equal. Okay, I just went to literally y equal. You see my original equation. So now let me put 116.45x plus 336,171.65 and 116.45x plus 250,431.97. Okay, got those two equations. If I hit graph, you'll see that's my upper bound and that's my lower bound. Now you see how it went through this one right here. That was the one that was off the most. Okay, if I hit just the trace button, okay, and I come over to, whoops, just was on it right here. You see that was my 22712. Okay. That was the one that was off the most over here, right? That was the one that was off the most. That was my biggest residual. Okay, on the next problem, they want us to find the price range for a house that is 2,800 square feet. So what I'm going to do, if I want a range, I'm going to be using my upper and my lower bound. Okay. So I'm going to be putting this into X here to get my upper range and this into X here to get my lower range. Now I can do that by hand, or I can come to my calculator. And when I'm in this, on the screen where I can see my graph, I'm going to go second and trace to go to value. I am going to be putting in 2,800. Okay. Hold on a second. Let me see. Just double checking my graph. Okay, this was out of my range. Okay, so two ways I can do this. Okay, the reason it's giving me errors because my calculator did not go this far in terms of my X's. If I hit window, you see my biggest X was this. So I could adjust that and just change this to, let's say, 3,000. Now it's going to be in there. And I just hit graph. Okay. So now I can go second and trace again. Once the graph starts. Second and trace again and value. And I can put in 2,800. Okay, now, right now it's telling me that this value here is on this one, which, if I move this for a second, is my original equation. Okay. If I arrow up or down, it's going to take me to a different one. So this is on my Y2. And you see that that value is, the max is going to be 662231.65. So basically $626,000. That's going to be my upper range. My lower range, if I arrow again, let's arrow to this one. Okay, you can see the equation at the top of this. Okay, it tells me which equation I'm on at the very top of my calculator. That's going to be $576,491.97. So this would be a reasonable interval. Now, if you don't want to do that on your calculator, using that, then what you can do is put it into these two problems. So let me go to a normal screen on my calculator. Okay, and I'm going to take 116.45 times 2800 plus 336,171.65. And when I put that in, you see I got that same answer I had for my upper bound. And then I do it into the other equation, 116.45 times 2800. This time plus 250,431.97. You see that I got the lower bound here. So I got both of these here. Okay. So I can either do it by plugging it literally into the equation or using the graph on the graphing calculator and doing value. Okay. So now on this, it says, what is a possible correlation coefficient? So on this, I'm not going to give you an exact answer. You can give me an answer, but your R for this is going to be greater than, well, let me do it this way. It needs to be somewhere in between 0 and 1. Now, it is not going to be negative because it's increasing. So if it was 1, that would be a line with every point on the line. As my points get more and more off of the line, it's getting further and further away to 1, closer to 0. So you can give me an approximation that you think it is for that. Okay. So then explain why you got that. So you would say something about why it's positive is because it is an increasing graph. Then you would explain why you chose your particular R. Again, the closer it is to 1, the more exact the line is with the points. The further away from 1, the more off the points are. Okay, a study showed a relationship between the number of ice creams sold at a local shop with the number of drownings in that neighborhood. The newspaper is going to have an article titled "Stop Buying Ice Cream to Decrease Drownings." Write a paragraph explaining why this example is an association. Be sure to include at least 2 lurking variables. Justify your thinking. So this is, since this is they want to decrease the number of drownings. What's happening here is if I was to graph this, I'm not graphing, I'm just going to set it up. And we are saying ice cream sold is here. And then here, this is drownings, number of drownings. What's going to happen is this should be an increasing situation, that the more ice cream, the more drownings. Now, that's not saying that ice cream's causing the drownings. Probably a lurking variable for this would be, for example, temperature, weather. Okay, I'll just put temp. The hotter it is, the more ice cream that's sold. Also, the hotter it is, the more people are swimming, which means there's more people in the pool that could, or in the ocean that could possibly drown. Also, if there are more ice cream being sold, it's so that would be an example. Another example is maybe people are on vacation. So they're out getting ice cream and doing things like that. But if they're also on vacation, there's more people out at the pools. To me, probably the best lurking variable in this situation would be the temperature. Okay, on this, I am going to multiply this out. 5x minus 2, x plus 4. So this is going to be 5x squared negative 2x. 4 times 5x is 20x. 4 times negative 2 is a negative 8. And you don't just leave it like that. You have to combine like terms. So you're going to give me 5x squared. My 20x and my negative 2x make an 18x minus 8. That is going to be your answer. On number 4, I'm going to distribute and get 2 minus 1 minus 4y equals 15. On this side, I'm going to combine like terms. So I'm going to get 1 minus 4y equal 15. I'm going to minus 1 from both sides. So I get negative 4y equals 14. I'm going to divide by negative 4, and I get a negative 14 over 4. You can reduce that or just leave it in that form. On number 5, I probably would fraction best this, times everything by 5. And when I times everything by 5, this 5 and this 5 are going to cancel out, and I get 35 plus x is equal to 60. I am going to subtract 35 from both sides, and I end up with a 25. On number 6, g of x is equal to 3x minus 2, and I want g of 2. That means I'm going to put 2 in place of x. So 3 times 2 minus 2, 6 minus 2, which is 4. On number 8, I'm going to graph. So the first thing I'm going to do is I'm going to graph my y-intercept. Okay, my y-intercept is 2, so I'm going to come up here to 2. And then my slope is a negative 3, which means I'm going to go down 3 to the right 1. Down 3 to the right 1. And then I can draw my line. Okay, and there's your line. On number 8, I'm going to raise everything to the third power. So 2 to the third, hold on, let me make this not as fat. 2 to the third, my x to the fourth is being raised to the power 3. My y squared is being raised to the power 3. So 2 to the third is 8. My power to power here, so my 4 and my 3 are going to multiply, and I get x to the 12th. My 3 and 2 are going to multiply, and I get y to the 6th, and that's my answer. And that's the end of this.